Hello? Hi, can you hear me?
Yes, I can. Hello.
Yeah, cool, awesome. So we'll be spending like 45 minutes on coding problem.
Okay.
Uh, like,
Yeah,
uh,
I I probably should mention, sorry, it's my first interview at the interviewing.io, so
sure.
yeah, yeah. Sorry if I would be a bit more slower than
No
than you
worries, no
expected
worries.
to be. Thank you.
Cool, awesome. So this is a problem we will try to solve. So let's say that you have a directed graph, right? And you have to find the length of the longest path from each node.
So, given a directed graph, find the length of
Mhm.
the longest path from each node.
Mhm.
Um, uh, am I understanding right? So we have a graph. So we have an amount of nodes interconnected within each other, right?
Right.
Um, and we at our starting point is some indication of a starting node, right?
No,
And
no. And for sake of this problem, what we want is considering every node as a starting point. What is the longest path from that node?
what is the longest path from that node to the leaf?
No, to any node. Like let's say that this is the uh, this is the graph, okay, and then the output should be like length of the longest path, which is starting from two, from zero is two. Length of the longest path starting from 1 is 1 because like you can go from 1 to 2 only. From 0 you can go to 0 to 1 and 1 to 2. So the longest you can travel from 0 is of length 2. And from 2 there is no outgoing edge. So there is no longest path, there is no path starting from 2. So for 2 it would be 0 and from 3 you can go to 2. So it would be 1 for 3. But let's assume that we had something like this. Also, then instead of 1, it would have been 2 because the longest path is like from 3 is going to 4 and from 4 to 5. So, yeah.
I see. Yeah, thanks for confirming it. So from the zero, we can go to the one to the two. From the one, we can go only to the two. From the two,
hmm
we can go nowhere. From the three, we can go um, to the two, to the four, and to the five. And from the one, okay, I see. Uh, so I probably should also ask you, are we searching for any language implementation, or we searching in like generic algorithmic
Um,
described?
so, yeah. So usually, typically in coding interview, you are supposed to explain your approach. After sharing your approach, you are supposed to analyze the time and space complexity for your approach in terms of size of input. And then you are supposed to implement it in any one of the language which you are familiar with, and that code need to be close to production, like working code. But you don't need to worry about getting an input from a user or anything. You just write a function assuming that input is provided as a parameter.
Okay, I see.
So for this example, so like what language you are familiar with?
Um, I would be fine to use Python if possible.
Python, right? Yeah.
Yeah.
So basically you are supposed to write a function, let's say that def longest path, which will take as an input like adjacency list and the number of nodes, yeah, in the graph, and return at the end of result, return the length array or a list indicating these values as output.
Okay, but um, I, I think the only part that is left for me to start solving actual problem is to understand like if we have something like this edge list and this edge list is sorry, I need to turn off my Grammarly because it
Mm-hmm.
yeah disturbing me. Uh, and it's like 0, 1, 2, 3, 4, and 5. How is relationship between them are set up?
Okay. No, it wouldn't be like this. So basically, it is a list of lists. Okay. So every index indicates the neighbors from that node. So from zero, there is only one neighbor, which is one, right? So at the zeroth index list would be just one node, one. From one, there is only one neighbor because you can go from one to two only, right? So that's why the neighbor of one is two. Adjacency list is for one is just of a single node two. From two, there is nothing, so it would be an empty. From three, you can go to either two or you can go to either four. So it would be 2 comma 4 for 2 for 3, and then from
Mm,
4 you can go to just 5, right? And from 5 you can, there is no node going edge going out, so it would be an empty for 5. Yeah.
yeah, now I got it. Okay. Okay, so yeah, I think I'm understanding the problem better now.
Mhm.
Yeah, give me a second to think of how to
Yeah,
approach
take
it.
your time.
Okay, so yeah, I start to compose things up. I think um, here what we might want to do is since we have edge list, we can uh, we can make something like we can at the first step we initialize some list of the size of the edge list with a number of zeros. So zeros is uh, least least possible distance that might be for the given node. Um, I think it would be. I'm thinking if there is an option to use depth first, first search here because it's looking like this problem.
I think, yeah, that first search is the right approach to think about. But yeah, think about like how you would approach. So,
Uh,
but yeah, you are right. So it's something similar. The first search is the right way to look at it.
I think we want to create here something like we want to first make um,
Mm-hmm.
make the nodes here in something like let's say correct order, and
Mm-hmm.
then we could just like go through the list and each time adjust
Mm-hmm.
the numbers accordingly, basically increment them, I think. So
Okay. So are you talking about topological sort?
yeah, I forgot the term. It's topological sort. As far as I
Mm-hmm.
remember, like don't hold me too much to it. We can make topological sort by
Mm-hmm.
implementing the depth first search, right?
Mm-hmm.
And go through each node and
Mm-hmm.
use depth first search into the each node, and this
Mm-hmm.
will give us uh, a reversed topological sort graph, right? It might be, yeah. I need to get the whole idea. And if it would be possible, what would be the next step? One second. So first we are finding the topological sorted tree, not tree but graph, and then we iterating through the whole through the whole graph, through the whole sorted graph, and checking the distance between node and their neighbor, and if and based on it we can increment the distance for the given node. So it would look something like, I'll try to drop something here, like we first we need to init distances list for the num of nodes. So yeah, then we need to create the topological sorted view of a graph, and then like for each node to check if the longest path for the node can be incremented by current node. And I think that's it. Like this is the 3 steps we need to create, but for the topological sort, it's needed to what? To make DFS for each node and then to reverse it. Yeah, I think this should work somehow like this. Is it looking promising or not? How do you think?
Yeah, so basically what I'm saying is, like, if you're applying for DFS for each node, you don't even need to do a topological sort. You can just start applying DFS till you can and find the length of a longest path for that particular node.
Sorry, could you please repeat it?
What I'm saying is, if you're applying a DFS for each node, right, you don't need to worry about applying them in a topological order or anything.
Yeah, yeah, you are right. I thought that the idea of topological sort is is to basically to sort the graph using the DFS.
Mm-hmm.
And is it right? Is this like giving the needed perspective for the graph?
Mm-hmm.
Yeah, maybe I can start from topological sort itself. Maybe I should like
Okay.
dive into how to make it.
Okay.
Um, um, topological sort, topological, oh god, topological sort. So number of nodes, and one more thing here is at least. Mm. So since BFS using stack, I need to make the stack.
Mm-hmm.
Mm, and I need to, uh, yeah, let's make like DFS first for the one node because
Mm-hmm.
I will go through the minimal to the bigger. So
Okay.
for adjusted list is a list, but is it like an index? Let's
Mm-hmm.
imagine for a second that is uh, just list is ticked. This needs to be fixed. But I'm just trying to remember the DFS itself. The neighbor in adjusted list node. I need to execute DFS on it on
Mm-hmm.
the not on the node but on the neighbor. And
Mm-hmm.
since I'm using stack, I'm using here stack um, and node, and I need a condition here. The condition would be is it that it should be like this. So oh, I see. I'm using global context here. But since we are in the one function, this would be enough. So here I should check if it visited and DFS it only if it's not. So this will eliminate the necessary uh, visits. Tag will contain result and visited would be each node is not visited at the first stage.
Mm-hmm.
Uh, yeah, let me quickly check what will be going here. So for each node, this node would be visited. This is node index probably. And for neighbor in at this node, if neighbor is not visited, then DFS neighbor. But visited here should be shared, and node will go to the stack since it would be sorted. So I should make it somehow like this. Um, E. Yeah, I'm using visited from the outer scope here. It's not very correct way to do these things. And the stack, do I have an option to run this code or not?
You can run this
Yeah,
code. Yeah.
but it won't work.
At top left there is run button.
Sorry.
On top left there is a button for run.
Okay, I see. Yeah. Give me a second.
Okay, I'm just taking a look at it. So is it, going to the DFS. Mm, where are you building the graph? Okay, you're using the same adjacency list.
Yeah, I now think that like we can iterate through the I see in my cursor like we can iterate from the
Mm-hmm.
from the result of this. So result return stack like minus one. Like we can iterate through the result of this sort and
Um, mm-hmm.
and check the node in the
Um,
original list.
so if
Yeah.
if you see, these output is nothing but the topological number for those nodes, right? In topological order, what is the number, right?
Yes.
This output is that, okay. And the next you will use this order to
Yeah.
run the DFS. Okay.
Um. I mean, I wanted to use this order like 3 4 5 0 1 2 to iterate through the original list
Mm-hmm.
and for the each list uh, to check for the each item to check his neighbors and if his neighbors is persist here, then increment the available distances for the given node. Is it working like in, oh, no, it's not. Um, I might actually be wrong around what is exactly topological sort is. I'm feeling that I'm missing something here, but at the same time, it looks like I have an idea of how how exact this problem could look like. So yeah, I'm just trying to. So the now going through this loop is to create something like distances, and now um, so this is the node 3. What about here the node 3? The node 3, the node 3 actually has two neighbors here. Looks like something wrong with complexity here. So we are checking neighbors in a regional graph. Hmm. Hmm. So for each node here, we're checking the node here, and we see like 2 and 4. So for 2 and 4, we need to increment the values. Something wrong here. something around here, but I know I can keep it in my head, so I'll try to like use sprints. So it would be longest part. And I need to bring distances here, like mm, this, and then bring
Mm,
It's looking like I forgot or I'm missing some conditions here.
mhm. I think like the number of the entries are same, but somehow like the output sequence is different, right? So the actual output also has two ones, two twos, and two zeros, and yours also has the same, but the sequence is jumbled, right? Because like you are going through the topological sort, but the actual output is expected as the actual number. That's the difference, I guess.
Hmm. Um, yes. Sorry,
So basically, you got an ordered graph, right? So
right.
you got an ordered graph, but like from ordered graph, you can use the ordered graph again back to build the result,
Hmm.
right?
Yes.
So you already have this distance, so you can just look at index of zero. Uh, an ordered graph is, let's say, something else. So the distance of zero goes to that place and build your result accordingly. Um, did you get what I'm trying to say?
Um, yeah, I'm thinking I missed some words here. Like, I got slightly inverse, result,
Hmm.
but, um, I'm not sure whether it's completely correct or not. I have like, it's just a random idea to, to make this, but yeah, it's obviously not correct. Um,
Mm-hmm.
so what is the problem here? I'm going through the node, right?
Mm-hmm.
For the node 3, where is the node 3? For the node 3, I'm checking the neighbors, and the neighbors are 2 and 4.
Mm-hmm.
Uh, so the distance for that node, So this is not, so this is the distance for this node. This is not the distance for the, this should be the distance from the top of the graph to this node. This is
Mm-hmm.
the issue. Uh, yeah, but I can't like simply inverse it
Mm-hmm.
and use and said that for the yeah, for the node 3, what should be improved is, yeah, I'm actually should not there increase the distance for the neighbor. No, I should increase
Mm-hmm.
the distance of the neighbor, but I should increase distance of the neighbor, I guess, conditionally.
Mm-hmm.
Like, um, if the distance of the neighbor is less than distance of the node plus 1, or it's
Mm-hmm.
absurd idea. I'm not sure. I'm not sure at this point. Yeah, I'll try. Uh, no, it's not fixing anything.
No. So basically, what I'm trying to say is your
Hmm.
ordered graph, right, has the
Right.
order in which your nodes would be processed, right?
I,
So this,
as I ordered the graph.
yeah. So basically, if order, if the zeroth node in the ordered list is, let's say, um, 2, right? Then the distance calculated in distance graph at zeroth place is the distance of for the node 2. So you can use the ordered graph to create the result from the distance. That's what I'm saying.
Mm,
Do you follow?
yeah. Yes. Yes.
Uh, what I'm trying to say is, let's say that you have a new result array, result of ordered of I would equals to distance of I for every node, for every I from 0 to the length of
Yeah.
ordered graph.
Mm-hmm.
Let's, you can do this and then like I can like print the result.
Mm, I'm stuck.
Um, do you know, do you follow till now? Like the ordered graph of 0 of I is nothing but the ith node. Um, like if I say that ordered graph of I is equals to j, right? So it
Right.
means that the distance of I is nothing but the distance of actually the distance is nothing but the actually the distance of jth node, right?
Right.
So what you need to do is, yeah,
Um,
ordered for I in range length of ordered graph, right? You do result of I is nothing but,
Isn't list of
sorry,
uh,
result of ordered of, sorry,
results of order?
is
Yeah,
nothing but distance of I. Yeah,
yeah. I missed
and
this
then print.
transformation. Yeah.
Yeah, I'm just print the result. We just need to declare the result. How to declare for length? I'm not sure in Python like how to declare. Okay, you already did above. Yeah. Can you run it? Yeah, let me try. Mm,
Probably we need uh
I don't know why it's still printing this. Uh,
um
I think this should have made it restructure. Let me print the ordered graph once.
maybe we can just iterate through the ordered graph without the index. Maybe the problem is here.
Okay.
I mean,
Mm.
yeah, I type here too. 345
Okay. Why index three? Okay. Why three zeroth? 0, 1, 2. I think 2 should be the first node in the ordered list, right? Because 2 has a 0 of degree. I think there is some flaw in the way ordered graph is calculated. Instead of 3,
Okay,
the 2 should be the zeroth
maybe
node, right?
the issue was here. No, it wasn't. I I mean that of our first node should be 2, not the 3, right?
Right. But yeah, I think like I understood the idea, and the implementation also looks very close to correct. Like there is small issue, but yeah, that's okay. Uh, I have one follow-up on this. Does this question work for cyclic graph? If graph contains cycle, will that this code work?
I think if graph contains cycle, it's unsolvable.
Mm-hmm. Okay.
Uh,
Uh, I think like it's solvable, but like there would be some modification required.
I would be um,
Like basically it depends like how we represent the cycle. Like, for cycle, we will represent the distance of node which are part of cycle as infinity,
yeah. Okay. Yeah. Yeah.
so
What I meant is that if the graph contains cycles, that there is a possibility that the longest path is indefinite.
right,
So
like we
we
can just
need
write
to
it as a infinite.
yeah, we need to have some like constraint
Okay,
or
and
use it. Yeah. You,
mm-hmm.
sorry, you wanted to
Okay.
ask something.
So what you are trying to do is like with some constraint, it is possible to modify your code. Is that correct?
Mm, I guess yes. I guess yes, but this would be like I'm not sure this would be like solvable in how it called polynomial time,
Mm-hmm.
since we have a cycles and we need to define a way to find the cycle and
Mm-hmm.
deal with the situation where the path is infinite.
Mm-hmm.
Yeah, most likely to find the cycles, we need to add some like um,
Visited.
uh, some function that would find a loops in the graph, a cycles in the graph,
Okay. Okay.
as the stage of the solution. So yeah, probably
Mm-hmm.
like even before they're sorting the graph or in the process of sorting.
Cool. Awesome. I think, yeah, those were the questions from my side.
Okay.
So yeah, so,
Oh,
I will be writing a detailed feedback after this
I see. Cool.
on the
Yeah.
platform.
Thank you for the interview. It was yeah. I needed to think through this interview, and it was a pleasure. Thank you.
Yeah. Have a nice weekend.
You too. Bye.
Bye bye.